Someone's asking about, can GPUs be leveraged to reduce compile times? You maybe could do that, but it seems hard. I mean, you'd almost have to put the whole compiler on the GPU. It doesn't seem like a good idea because the round trip latency going to the GPU and back is so high that you have to get a big win for it, or things have to be very, very deeply pipelined, both of which are possible. You know, certainly I would be trying to make things as fast as possible on the CPU only before resorting to such a thing. How many times have I come across these surprising combinations of rules, such as the operator overloading being a normal procedure and procedures being assignable function pointers? That's not necessarily an uncommon thing. Like when you design a programming language, you're trying to let stuff like that happen, right? Because that lets people do things in the language. Sometimes actually you want to not let stuff like that happen if it's going to be very error prone and cause problems. But usually if it's only good, you want to let that stuff happen. I actually don't know how this stuff is handled in C++ because I don't use operator overloading very much in C++. You know, in part because it tends to lead to header programming and stuff. I don't know. Maybe, you know, I'll probably use operators more here. Maybe, maybe not. But so I haven't experimented with them that much. So it's possible that you could do exactly the same thing in C++, maybe. Maybe not. I don't know if it's legal. So this guy's asked me this question several times. How functional programming do I want this language to be? Will there be support for ADTs? I almost don't even know what that means. Like I'm assuming by ADT you mean where you have a common interface and you don't know or care what the data is and you're just calling methods on it. I mean, that's kind of what an object is or something, right? Like in a object-oriented language, or I mean, it's what generic programming is. So I don't know how you don't support ADTs, really. I mean, even in C, you can just agree upon a convention for here's the methods that we call to do certain operations, and then you define those for any data type that you make. So it's not particularly convenient in C because you can't do stuff like have that version of lerp that operates on everything or whatever, but so it's almost kind of a meaningless question to me. Like I don't even know what you're asking when you ask that. Someone's saying they like the cross way of calling functions because it makes mathematical expressions much nicer. They would fight to keep it. Yeah, maybe. I mean, that was the idea. We'll see. I mean, so the thing about languages is every new thing, every new feature adds complexity, which then eventually may bog things down. So what'll happen is I'm going to leave that in for a while, and then we'll see if it pulls its weight. We'll see if it's useful relative to other things, and if it should be cut or kept. I'm leaning toward keeping it. I could see the syntax changing a lot, like finding more useful ways to write things. Like maybe you put arguments inside the operator, right? So maybe the operator, maybe if you do something like this, cross is a dumb example, but you know, maybe if you do something like this, you can put more arguments in there, right? And this is then like an implicit first argument, and this is an implicit last argument. That sounds confusing, but then, or maybe this is implicit second argument, and these are extra arguments that are optional. It sounds like that might just be confusing, but actually languages go that way a little bit for other reasons. So You know, you have like the trailing lambda in languages like Swift where you don't write it in the arguments because it's inconvenient to do that. So I don't know. I mean, I'm not saying that specific thing is a good idea, but I can see the notation evolving a bit. So someone is asking about bucket array in the subscript operator for bucket array. What is the difference between returning a t here and returning a t.type? So t.type is the type of the element stored in the array. It's a different thing, right? So t.type is this, right? Which is, for this bucket array I made, is float, right? It's the thing that I store. I could have called this element type or something, and in fact, probably I should do that in terms of designing a standard library so that it's more understood from context what it is. But, you know, this is not the type of t. T is a type, right? This is the element type of the bucket array. So we're saying here that subscript returns float because this bucket array is a float. Someone's asking, what have I done more complex program-wise? I'm going to save that for later because I don't want to totally spoil what game we're working on next. And if I show it on the stream while it's crappy, then that's not a good way to reveal your game. Someone's asking, can I do ternary operator using tuples and stuff? Not right now. But like I said, you could imagine that syntax for operators expanding to include arguments. Are these custom operators designed to be fully usable with the metaprogramming features such as templates? Yes, they are. In fact, this is a bad idea because this is really new code and I haven't tested it, but let's do something crazy. Let's say, let's define an operator like double less than. Let's define it to be a lerp. Oh, that's really asking for it, right? So we're going to say it takes an argument t, a of type t, b that's also of type t. It returns something of t, and it gives you the thing halfway between those two things, right? This seems like a really bad idea, but let's do it. So what are some we have, let's pick some vectors. So we have v1 and w1 are these vector 3's, right? So bad idea 1, v1, w1. Let's see if this works. I won't be surprised if this doesn't work. Just because I haven't really tested this outside the demo. Let's see. Haha, it worked. It worked. Right? So here we have a polymorphic operator that calls another polymorphic operator, etc. Now, to spice it up, let's make another one that doesn't apply to vectors at all, right? A float, or if you pass it a string and another string, it'll return bool. This would be really bad programming style, right? Because these are two overloads of the same operator and they do totally different stuff. This one gives you halfway between the things. And this just tells you if the strings are equal. This is like aliasing this to equal, whatever. But so now this should still work, which shows that it's doing a smart choosing of the operator, right? So we still got the right answer. But now I can say different strings returns, right? And then the arguments will be, or we'll say hello sailor, right? So the argument is just going to be applying that operator to these, and should say false. Oh, I didn't, my debugging. Oh, it's, okay. No. Here's the trick. Here's the trick. Oh my God, I can't believe I'm going down that far down this road. The problem is that this thing accepts strings, but then applies lerp to them. So now I have to remember how to do this. Oh God, it's been so long since I've done it. Okay. If t is equal to string, is that how modifiers work? Let me look up. What the hell is it called? There we go. See, I've changed modify a couple times, so I just want to, okay. So if I do this, then I should reject string as being an argument here. Let's see if, I don't even know. All right, that didn't work. So there's still a little work to be done. It was bananas for me to try that, but that'll work eventually. I wonder what's going wrong, actually. I don't exactly understand. Oh, you know what it is? I bet this is hard-coded in the compiler. So this actually, it's not even getting to the point where, you know what, since it's Q&A, let's go look. I bet does not apply to, yeah. Okay, so we have a hard-coded thing where we were trying to give good error messages before, where we check our operator, and if the argument's a string and it's not a logical operator, we just refuse. Where now that we have overloadable operators, we don't want to do that. The thing, I'm just going to uncomment this for now. I probably need more sophisticated checking here because now I'm taking away error checking that might need to happen later. But because we're on a roll here, let's just recompile the compiler and do this. Now, the other thing that I mentioned would have been a problem anyway, like both procedures would have accepted. Oh, you know what? And while we're doing this, I have this operator to string, and it doesn't have everybody, which is why the error message didn't have it. So it's this one, right? And really, it's because I haven't done that much operator overloading in regular programming, because I just finished this feature, that I haven't noticed that not everything's in here. So what I should do later is audit this. Now, really, your programming language should tell you when you didn't cover all the cases, but that's a whole different story. All right. Oh, I'm running the wrong. I gotta run the GC x64 release. Oh, see, I've got more hard-coded stuff. See, this is just what happens. So I'm going to have to audit all this checking carefully later, but I hit the wrong key. Visual Studio is slow. It takes so long. Oh, now it crashed. All right, so that's not a surprise. Once I start doing that kind of stuff, it's not a surprise. So what's going on is just it doesn't expect me to overload that operator. You know what? I could overload a different operator. You know, why? Since we're in Crazy Town now. Okay, first of all, let me just do this. Let me overload plus on string without it being confused. And all right. Too much hard-coded checking. Yeah, I just have to go redo all that checking. Sorry. It's what I get when I don't test everything in the universe before getting a demo. But, okay, so the short answer is that, so we did demo a polymorphic operator. That works. And I was going to do this disambiguation thing, and that didn't work. So let's go back to the thing that worked. So this is a polymorphic operator that calls another polymorphic procedure, and that's all great. I answered questions about handmade compiler at the beginning, so you can rewatch the video. Or no, maybe that wasn't recorded. It'll be in the Twitch archive. Someone's asking about swizzling. Like in GLSL or something, you could say, you know, v.xxx if you want the vectors component 3 times, or you could say v.zyx if you want to order the elements or something. I've thought about how to do that the best way. I do feel like that's the kind of thing that is maybe best put in the compile time metaprogram and not as operator overloading. Because the reason is just there's all these, imagine if you have a 4 vector, you have 4 to the 4th possibilities, right, that you could put here. And, you know, that's a lot. So defining that many operators would be goofy, right? So you really want a different mechanism for implementing that. Where's the heckler guy who said that everything... Yeah, where's Meep Darkness Meep? Where's your question, dude? I'm waiting for your question. Maybe it's further down and I have to scroll down. Oh, there it is. If this isn't a JIT compiled language, why does compiling time matter? Compiling is a time where it should optimize everything it can until it can't anymore. Compile times mean nothing in precompiled languages. You would not believe that if you had a career as a professional programmer. It means a great deal because it controls my iteration time, right? If I make a change to the program and I want to evaluate that change, if I want to test it, make sure it works, see what happens so that I can think about my next change, then that time of iteration is gated by the time it takes to compile, right? Compile time cannot be too short. Now, that's different from saying, well, maybe I want to spend a lot of time doing a lot of really serious optimizations. Now, maybe that's true. However, you save that for like a release build that you only do once in a while, right? That you don't sit there waiting for. You know, I mean, I've worked in jobs where I was waiting 45 minutes to an hour for things to compile, and it just kills productivity. You can't get anything done, right? Whereas on the other hand, if it's instant, then you're very happy. Now, all that said, you know, so I've said, well, maybe if you want to do a lot of optimizations, maybe that's slow, and that's all true. However, I think you should be able to do most optimizations that you care about almost instantly, right? A lot of these things that compilers are doing now are optimizations to sort of get around bad programming practices that you probably aren't doing if you know how to write fast code in the first place. and or very questionable optimizations that break language semantics that a lot of programmers don't even really want, right? So if you actually take the set of optimizations that we really care about and that consistently do a good job and that are predictable, right? In terms of if I'm a programmer, that I know what the compiler is doing to my code, I think those optimizations have been understood for a long time, and I think those are the important ones. So you can probably turn most of those on and still compile very, very fast, right? And then, you know, if you want to bring out some kind of big optimization guns for later, then that's fine. But part of the thesis of this language, so there's this idea that has sort of been around for decades. Like I heard it when I was in college, which is like, you're not smarter than the compiler about how to make fast code. That is complete bullshit. Like a good programmer is so much smarter than the compiler, it's really not funny, right? Not about like little peephole optimizations on a particular architecture, like a blah, 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 but about like, here's how I'm gonna arrange my data to make my program run 1,000 times faster than it ran before, right? We do that all the time in this business. The idea that a compiler can compete with that is completely like patently absurd, in fact, right? And I sort of feel like there's a giant cultural gap, right? So the people who in the world really write fast code, right? The people who actually know how to program efficient programs do it algorithmically and by rearranging the data. They don't do it by the kinds of optimizations that compilers do, like lifting values out of loops or something, right? I mean, that stuff helps. It's good. It's good to have that. But that is not the real work, right? So part of the thesis of this language is you want to enable people to do the real work. And you want to do all the things that for them would be tedious, but that they want to happen. But you don't want to do things that they don't want to happen, like all these crazy optimizations that are making their way into Clang and GCC now. So kind of the idea is that the programmer is ultimately the person who makes sure the program's fast, not really the compiler. The compiler is just like a workhorse that does the things you expect it to do, if that makes any sense. That'll make sense to all the optimization-minded good programmers out there, and if you're in school, what I said may not make that much sense, but it totally does. But that wasn't the actual thing that I saw you heckling about during the talk, so if you want to ask that question, let's see if it comes up. Did I ever make any headway on a decision about short-circuiting? Yeah, I'm pretty sure and or, logical and logical or are going to be short-circuited, and it's just on the to-do list now. It feels like the right thing. I just didn't do it originally, not even for any reason, but just because I don't want to blindly copy what other languages do. But I'm finding myself missing it, and it seems like an error-prone thing not to have, right? I make crash bugs when I don't have it. Maybe that's just because I'm really used to programming in C or C++, but usually the way you fix those is by adding extra lines of code. So it feels like short-circuiting is the right thing. Someone's saying, I don't like half-quoting unary operators. Why not figure out whether an operator is being used as a unary operator or as a binary operator? Well, I thought about that. The thing, though, is that it's grammatically ambiguous at some point. So you kind of don't know. Like, let me see if I can come up. Let's say O is our operator. You can make an expression like A, O, O, B. Is that going to be ambiguous? So say there's one overload of O that's unary and one that's binary, right? So that can happen. Maybe it doesn't even have to be the same operator. Let me think. So if this is unary and applies to A, and this is binary, right? Or this, I mean, let's do double quote because that's what you're saying, right? Or this could be unary and apply to A, and then that could be unary and apply to A, and then B is, I don't know. This case isn't quite ambiguous, but I was convinced when I was thinking about it that there are cases that are. It's very easy to introduce ambiguity into a grammar by mistake, so I'm just watching that. Usually when I introduce new syntax, it's overly constrained. So like, I have all these colons all over the place that are probably more than I'd really like to type. And the reason I do that is just keep things very unambiguous for now, but the grammar will be revised to lighten it at some point, I think. And this is just the same thing. It's like I may be overly using the single quote, but the point is to not make mistakes early. Someone's saying, sorry, I missed this. Is it possible to concat with a string and total length is add all the lengths of the strings to allocate memory from a new string and do copies, return a new string? Yes, that is possible. In fact, that is in the standard library. Here is a concatenate function. It's varargs. It takes some number of string inputs. It returns a string. It counts up the bytes of all the strings. It allocates a return string. And then copies all the strings and returns the result. It does exactly what you said. It's very convenient to have. Someone's asking, can you use baked functions as operators? Yes, because they're just functions. So anything will work. If I had a 100% accurate way to tell if characters an emoji, would you allow people to define emoji operators? Well, let's go broader than that, because a lot of languages, and I think it's a good idea, are generally allowing most Unicode characters to be valid characters in an identifier, right? An identifier is just a name of a variable or, anything like this, right? So if you speak, Arabic or Hindi or something, or Japanese, you might want to have variables in your own language. That's totally not an unreasonable thing. In fact, it's kind of absurd that more languages haven't done that. And so by the time you do that, you kind of are supporting emoji unless you explicitly ban happy faces, which I might do. That's the kind of thing I might do, but yeah. Someone's saying GADTs can recurse on their own structure. Look here for an example. It's a common thing in languages that support structured pattern matching. I don't know. I'm not thrilled by pattern matching. I used to program in ML, in standard ML of New Jersey. I spent like a year programming in that. And that was all pattern matching all the time, and I'm not convinced it's any better than anything. But I haven't thought about it. I haven't done the switch statement for this language, so I haven't thought too much about it. I don't have any plans right now for regular expressions. That seems more like a standard library thing. Yes, I'm planning on doing game libraries. In fact, I'm going to ship a game in the language and give people the source to that game, so people will have a good starting point if they want to make things. At this point, there's a lot of chat, so I'm just scanning for things that are highlighted with my name. So I might miss some if they're not highlighted. In lieu of having some mechanism to enable user-defined precedence, is there value in having no operator precedence at all and having strict left association always? Well, that is how it is. Oh, you mean no operator precedence at all, even among math operators, maybe, is what you mean. I thought about that for a second. It just didn't feel right to me, but I honestly don't know what the right answer might be there. Maybe that's the right thing to do. Can't tell you. But I feel like I would have to go over my code right now and audit it and fix a bunch of bugs and put parentheses everywhere if I made no precedence at all. So not totally loving that idea, but who knows? Can you compile this to JavaScript? We'll talk about that in a future installment. Will I write an OpenCL compiler for the new language? How else will we be fast? Why do you think an OpenCL? Do you mean in terms of implementing games or something? You can call out to anything you want. Like if you watch previous demos, like I do rendering and all that stuff. Like that's not interfacing with externally compiled libraries is not a problem. Okay, someone says, I have very serious issues with symbol blindness. I can get around some of this in C with a series of defined statements. How flexible is a preprocessor to remapping syntax? Is it like C and very heavy with symbols in the syntax? Okay, here's the deal so far. There is no official preprocessor, and I don't think there will ever be one in terms of there being a thing that automatically runs before your source gets processed, as there is in C and C++. Because my goal is to make the language good enough not to need it. However, that's not to say that preprocessing isn't very useful. It's very useful a lot of the time. So I think what is going to be is there's going to be a preprocessor supplied in the standard library that you can put your source through at compile time. And that way it can be whatever preprocessor you want. You can put it through 5 preprocessors in a row if you want. They could be anything, right? And there's a demo on YouTube where I show the basic mechanics of how that works. It doesn't have all the convenience features that I would put in eventually, but there's a demo where I start up the compiler, I make a workspace, and I just start, I like rot13 some strings. Like rot13 is a text processor that just adds 13 to each character. I do that and like add them to the code and stuff. So when you see that, you can imagine how an arbitrary preprocessor would work. So the answer is actually, you can already today arbitrarily customize the syntax with any preprocessing code you want, and you can write the preprocessor yourself if you want. The only thing that's missing is maybe some small convenience features to make it easier later. And maybe a standard preprocessor in the standard library if you don't want to write your own preprocessor. Can I pack an MP3 of Sabotage by the Beastie Boys in your next keyboard without exploding? That's what I should do next time we play some music, because it should be Sabotage, except then we'll get muted on YouTube. How big is the team? It's mostly just me still. However, someone else has come on to help out. And we'll talk more about that next time. I'll show his work, and yeah, we'll make that an official session. Someone's asking, Maxwell Perlman's asking, can I set a character to be an operator like AXB? He's basically asking if you could write cross product like this. I don't do that, and the reason is just because I don't want to make parsing the logic of parsing depend on where in your program you are. You wait for the siren to go by. Like the way that the parser would construct a tree out of this code depends on whether you've declared X or not as an operator. And that could happen arbitrarily far away. It could happen in a different file. It would mean that anytime you saw an identifier, you probably have to wait till things were parsed. I don't know exactly. It seemed like a bad idea. I thought about it for a second. It seemed like a bad idea. In general, so C has this problem, and C++ inherited it, where you can't really parse the language if you don't know the types, right? Because there's too much ambiguity otherwise, and so you need to know what all the type defs mean and stuff. I don't want to repeat that kind of problem, right? Especially if you want the compiler to be very well pipelined and very nonlinear as it is right now, right? Like you can parse code in isolation without knowing the content of the rest of the program, and I would like to keep it that way. So that's why I haven't done that. Mike Acton recently talked about debugging in the release build versus the debug build. Do I prefer debugging symbols in order to inspect data while debugging? I do prefer that, although I did just yesterday, twice in a row, debug things where I was directly inspecting memory rather than using much in the way of symbols. So it's very good to be able to do both, I think. What features have I removed? Nothing too serious yet. When I talk about removals, that's mostly a future thing. Actually, at this point, I'm just scanning for my name because there's so much chat. So if it's a big question and it doesn't have my name, I maybe didn't see it. How does multi-return work? If possible, please show an example. I mean, I did show examples of multi-return. You say return with two, whoops, say return with two things, right? And I've demoed this. I have a demo that's mostly about multiple return values, so I won't go into it too much now. You can look that up on YouTube. Internally, what it is it's just the same as, so the calling convention is that the caller actually supplies the memory for these return values and gives the pointer to this procedure. So it's not like the C calling convention where things get like copied a lot of times, right? So in theory, and we haven't been too serious about optimizing the back end, but in theory, when you do this kind of assignment, you don't even need to have any temporary values at all. This can get assigned straight into the memory in the caller that is reserved for this return value. So it should be very fast. In fact, it shouldn't be any different than in C++ if you passed like what's called out parameters, basically just an explicit pointer to a place to store a value. It should be about the same as that. But we'll see. Oh, well, and it should be faster than out parameters if things are register size, right? Because if you want to return 5 floats here, then here you can just return those in registers or just in memory directly versus taking an extra level of endure. Well, you have the option of returning them directly in registers, which you don't have without parameters. We haven't, when you define a calling convention, then you need to define things that you're going to stick very closely to, like in certain kinds of cases, what goes into registers on a certain architecture and what doesn't. We haven't done any of that right now. So this is all just me babbling about what probably happens in the future. I should really fix the left token to be oh, yeah. I'm not going to save this. This is going to get reverted anyway, so it doesn't matter, but thanks. Wow, there's a lot of questions today. Once I'm happy with the feature set, do I intend to release a compiler as library? Yeah, I would like to. Like right now, I still only have a command line interface, but making a library interface should be relatively straightforward, I say right now. I'm not really thinking of anything that would make that a problem. I mean, the most annoying thing is just making sure all your dependencies are there. Like, if you want to link to OpenGL, you need the GL, DLL, and whatever, right? GL, DLL is often installed by default, but pick something different. Like, if you want to call out to like STB image, then you need to make sure that DLL is somewhere that you can find it, but maybe we'll package that data in with the library somehow. I don't know. If most arbitrary Unicode characters are allowed, would you consider allowing single character custom operators? Well, maybe. I mean, it's just at that point, you need to, like I said, I want parsing to be independent of semantics. So you would need to define ranges of Unicode of like, these things count as operators if they're on their own versus not. And there's some areas that might make sense to do that with. It's just it starts getting complicated, and then eventually you're like, this is bananas. But you know, there's some basic stuff. There's an area of Unicode that's like, hey, here's a bunch of math operators, and those probably should be operators. I don't know, man. At some point, things just get complicated. When you start dealing with language, things just get complicated. And yeah, I would like to keep things as simple as possible, but I would also like to do the right thing. So yeah. Are unions and anonymous structs supported? Yes and yes. However, union support is not great right now, but if you look at previous demos, you will see what I do for the equivalent of unions. How nicely do I feel things interface with libraries like OpenGL? It's just fine. It's just like anything. I mean, it's not really any different than what you would do in any programming language. Like interfacing with external DLLs is kind of the easy part. How close am I to shipping? I've answered that question 3 times today. Please review. I mentioned in an earlier demo that we would have C++ concepts or equivalent by 2017. Is this still a realistic timetable? We already have that. Unless you mean some weird corner case feature of concepts. But no, dude, we've had better than concepts for months and months now. If you go back and watch the YouTube videos about polymorphism and type arguments and like struct arguments, just watch like the last couple at least, and you'll see some stuff. The one thing that you may want more of is, again, notational convenience, right? Because you can arbitrarily program anything, right? So if you want to say, hey, this procedure takes something, and that something just has to conform to a certain interface. It has certain names and certain types. The compiler doesn't have that built in. However, you can very easily write a procedure that does that. And the question is just, well, could that be made more convenient? Maybe. But I want to see how that works out in practice. It's probably still more convenient than C++ no matter what. So, yeah. Someone is saying they remember me talking about how parsed tokens are stored in a tree. How is this advantageous and how are you using it? That's a totally standard thing that compilers do. Most compilers, almost all compilers, have a phase where the code is represented as a tree in memory, and then maybe they do transforms on that tree, or maybe they convert it to something else. But it would be very rare for a compiler not to do that. It's just a useful form. So when saying, what do I mean when I say baked functions, cannot find a source? If you look through the YouTube clips, look for the polymorphism demo, which was a while ago now. It was like a year ago. And you'll see what that means. It's a cool feature. Do I think people will be able to start programming in this before 2018? Yes. So someone said, when I mentioned ADTs before, I meant abstract data types which are based on set theory. I don't, there's this whole category of programming language people who want to do things based on set theory and stuff. And that's fine. It's a cool area of research and thought. I just don't really know how it helps to solve real world problems that I have every day. Maybe it'll turn out all that stuff is super useful, and maybe in version 2 or 3 of this language we will want it. But for version 1, I would characterize the language as most of the high-level features are in place. Most of the big features. There might be 1 or 2 more, but even we're getting now down to like medium-sized features at some point. So I'm not going to put stuff like that in, because I don't really see the use, honestly. Now, again, that might be due to my limited experience, but I've never seen an explanation of that stuff that was convincing to me as someone whose main interest is in producing a lot of code that is fast and understandable. So if anyone, let me put up I haven't done this yet. So as always, you can email me with comments and opinions at this address. This is not a mailing list. It just goes straight to me. I don't reply to everything. In fact, I don't reply to most things because I'm just really busy working most of the time. But you could email me there. I'll at least read what you write. And so if you want to try and convince me that algebraic data types are amazing. Oh, ADT meant algebraic data type, not abstract data type, right? Is that why? So there may have been some confusion because I saw ADT and read abstract data type, which is like an older acronym. If it meant algebraic data type, then I totally answered that question with the wrong answer. If I thought about adding else conditions to things other than the standard if, you know, there's some language that does stuff like that, that has like for else and while else. I forget which one it is. Like I say, it's a serious programming language. And I sort of thought about it and was like, nah. Maybe it's like Ruby or something, or maybe it's Python. I don't even know. But it just doesn't see, that kind of thing isn't a high priority feature. It doesn't really solve problems that I have usually. But maybe, you know, I can keep my eyes open and see if that would simplify things a lot of the time. Do I think you could overload double ampersand and get short circuit semantics? Well, probably not by default, but in the same way that I had, in the same way that I have that, I could do something like short circuit, but it would still have to be a little bit hard-coded because, like, what does short circuit mean for time? Nobody knows, right? If it's an operator and, then we can infer that, and if it's an operator or, that's a different short circuit, right? That's an early out if something's true. So I could imagine adding that, but although wait. Yeah, I mean, I could imagine adding that, but it would be a relatively half hard-coded thing. So who knows? Are return types non-ambiguous? Well, return types always have an arrow, right? So that arrow doesn't mean anything else in the language, so you know the return type comes after that, unless I misunderstand the question. How big is the any size? It is currently, I believe, it consists of an 8-byte type value and an 8-byte pointer to where the actual value of the thing is stored. I cover that in an earlier demo. Can I do return open paren a comma b? I don't think so right now. I just didn't program that syntax. It's easy to put in if people really want it. At some point, I used to do that. I used to put parentheses around all my returns because I like the idea of thinking of it like a function because I came from functional programming sort of a little bit at some point. But you could think of that as calling the continuation or something, but it's not. It's just, I've come down on the side now of just preferring to have lighter syntax in my own programming. So in C++, I never put parentheses, and I just haven't programmed it here. Although I think this would just parse anyway, right? That would just be a parenthesized expression. However, right, this is not, there's no such thing as a tuple expression, so that actually wouldn't parse, actually. So I don't know. If people really want it, I'll put optional parentheses around return, but I don't in particular care. Am I receiving much friction from zealots of other languages? Only a little bit, you know. Hypothetically, if most of the world doesn't adopt your language, will you still use it and update it regularly for the foreseeable future? My plan is that I use this language for the rest of my life and modify it as need be. We'll see how realistic that is. I presume it is. And in fact, I think that's one of the things that might help encourage other people to use it is if they know that I'm using it and shipping games on it, then that means that it will be and continue to be a viable platform for shipping games, which sort of eliminates some of the uncertainty that you might have around some things. And I care about performance and frame rate and stuff, so more so than a lot of people making programming languages. Someone's asking about inheritance. There is no inheritance in this language. So, I mean, there's the using thing, but that's not really inheritance. So you don't have the same kinds of issues that you have. It's really namespace importation more than anything. We still haven't thought about threading models very much yet. Meepo darkness meep is a meep darkness meep is a heckler dude. When's that guy going to ask his question? He was all saying, "Oh wait, maybe that's it." He's saying the question that I talked about during the stream wasn't very focused about the language, just about my implementation of a function. We talked about this before, about how the compiler is not as smart as the writer, and this is implied here too. I actually don't understand that. So I presume maybe you're saying something about multiple return values, or maybe something about operator overloading, or I'm not sure exactly when during the stream that came up, but I don't know why anything about the way I'm doing procedures would have negative performance implications. Was it the fact that when I was talking about things are implicitly passed by reference? Is there a reason why you think that would have negative performance implications? Because the reason I said probably by reference is that because you can't write to things, and then besides that, it's a subtle point, but in general, you're not allowed to assume that you have a reference to the same thing the caller had. So the compiler is free to copy values and pass things by value if it believes that that'll be faster. So I'm not preventing that optimization. The compiler can optimize for cache coherency that way, but I'm just doing it without placing on the programmer the burden of thinking about whether something's a reference parameter or a value parameter. Actually, in that respect, it's more trusting the compiler to do the right thing than otherwise. And in fact, maybe I should add keywords that permit you to not trust the compiler and to force certain things to happen, because that's the spirit of this language. But I'm not sure I understand the comment, really. I'm not. If you could elaborate on what aspect of the demo you think is going to be slow, or what aspect of the language that is evident in any of this that you think is going to be slow. Wow, so many questions today. I'm going to keep going, but man, this is way longer than these usually go for. All right, can I say how I'm compiling code into bytecode and how I'm running that bytecode? I'm just doing it. I'm not doing anything except the obvious thing. So it's, you know, I'm not going to go into an explanation of how that kind of stuff works. It would be a long explanation. Just if you know what bytecode is, I'm translating to bytecode and I'm running it. You know, maybe when we do handmade compiler, we'll go into an explanation of that. There was 3 messages there. Oh, okay. Let me go to the other 2 messages. Writing error checking routine in a getter function is bad practice. Oh yeah, that was the thing. Writing error checking routine in a getter function is bad practice in optimized programming. You should allow the programmer using the API in their code to ensure that the bounds are correct once instead of doing it every time. Okay, wait. So first of all, so you were talking about this stuff here. Okay, first of all, anyone who programs in C or C++ knows that assert compiles out in release build, right? This compiles to empty lines of code in release build. So this does not impact the performance of a release build at all, right? It does impact the performance of a debug build probably. And the question is, do you, so that might be, maybe you come from the functional language world or something and you don't know what assert is. I don't know. There's a certain amount of cultural assumptions that I'm assuming here, right? So, you know, the question is, do I want to provide a way maybe to make this bounds checking not impact performance on debug code? And I think once we have the equivalent of if-def, you can just do that. Like we don't have an if-def right now, but you would just do like if-def array bounds checks, right? End if, and then you could do that at compile time, right? Once you can do either of those things, I honestly don't understand the objection, and I especially don't understand, because the other part of the objection is, you know, allow the programmer using the API to ensure that the bounds are correct once. That's error prone because people are not going to do that correctly. The bounds are going to change or something. The bounds are going to change, or the value is going to change, or they'll forget to do it, or they'll do it too many times, whatever, right? The way that you make things robust is you do it here, right? So I believe this is the right place to put it. If you have some reason for thinking this isn't the right place to put these things, then maybe you could do a follow-up, but I really don't at some level understand the objection, honestly. Okay, third message. In this case, the bucket only holds 0 through x minus 1 items. Given that knowledge, we should ensure the capacity of the bucket is at least y, and then you can know all the valid arguments you can give to the function. So you're talking about the programmer thinking really a lot about self-bounds checking the things or something, but that's not, you know, so, oh, you're talking about, okay, you're talking about this one, right? This is not meant to be production code, okay? This is just me covering all the cases, right? If I wanted this data structure to be fast in production code, I would either do something like this again, right? Which again, we have no if-def yet, but we'll have something like it. Or I would assert on those values, right? See, if you don't take anything like this too literally, like it's just me demonstrating functionality, right? To say stuff like, oh, your language is going to be slow because I typed an if statement is pretty weird, let's be honest. if that's what you were talking at this point, I really don't know if that's really what you were talking about, but it seems to be what you're referring to in your third question. I mean, this is totally the right place to put a bounds check because it's the only place that doesn't invite errors, right? If you give people an API to check their bounds of their bucket before they dereference it, then that's decoupled from the dereferencing and they will make errors and you'll have a higher error rate, right? The only place you can check it for sure and know for sure that you've checked it is right before you use it. Right before, with no opportunity for anything in between to change the values. Will I get to a point where I need to hire a full team to complete the language, or will I be working primarily solo? Well, there's already someone helping, and we'll see. It depends on what I can afford. I'll spend as much money on it as I feel like I can afford. I don't use entity component systems. I don't understand why people do that. I've never written a game that uses an entity component system. I guess Casey sort of does for Handmade Hero, maybe. But I don't. I do things that are simpler than that and that work fine for me. So, hey. Do I have a strict criteria for determining whether a new keyword like symmetric is hashtagged? In general, not completely, but you know, it's a bad idea to use too many keywords because those are things that people could use for variables, right? So in general, hash to me means like compile time operation or notation. So anything that vaguely feels like that kind of a thing is hashtagged. However, like right now, inline, for example, is not hashtagged. So you could inline a procedure call at a calling site. Where's a procedure call? So like I could inline print or whatever, and that would work. And that's not this, right? And simultaneously, if I define a procedure, you do that and not that, and maybe it's not completely consistent. Maybe the only reason I didn't put a hash there is because that's how it is in C. I don't know. We'll see. All these things, all these syntactical things will change. All right. If not entity component system nor multi-inheritance, how do I design my games? Well, I tend to have one level of what you would call inheritance, where there's a base thing that's an entity, and then everything else is a kind of entity. So a door is like one down from entity, and a human is one down from entity. And then just those have all the code that makes them do what they do. That's it. It's like a one-level inheritance. The simplest kind of inheritance that you could think of. All right. I've been talking way too long, so I'm going to take a break. Someone's asking what length features have I found most useful? I don't know. It's too early, but also everything's useful, which is why it's there. I'm going to head out now and get some dinner. Thank you, everybody, for coming, and thank you to those people who stayed for 2 hours plus. That's a long time. I'm going to be doing some more demos sooner than later, probably, because there's a backlog of things to show. So we will see when the next one is, but hopefully within a couple weeks or less. Goodbye, everybody. See you later.